Hey friends, welcome back to the channel and my programming showcase. I'm going to continue on with what I was talking about last video, which was about my OpenGL program and how it draws shapes. And I want to talk about this time drawing a cone and specifically texturing that cone. So if you are looking at the description down below, there should be a link there linking to this particular program that I wrote. And it has a bunch of different methods in here on how to draw different shapes. And then, of course, it's got a scene builder app as well that is designed to help you with drawing the scene of shapes that you want. Now, I'm going to talk a little bit more in detail about how all that works, but here's the gist basically. In the scene builder app, the first thing that you need to make sure you do is change this string here to match wherever your textures are going to be located on your computer. So if they're going to be on your desktop, you need to make sure that it's located on your desktop. You need to make sure that it's a folder, whatever the name is. Mine was located in this set of folders, and the folder was ultimately called textures, and that's where it ends. And then we concatenate the texture name to this string later on in the program. But what's really important here is starting here after users, make sure you change this name obviously to your username and then the rest of the program or the rest of the folder path. That's going to be really important. Otherwise, it will not compile, it will not run. It'll compile, but it'll give you an error saying that it can't find the textures. So make sure you use the correct path for the folder. All right, and I'm going to talk about all of this in just a minute, but instead I want to start off looking here. In this particular program, I want to focus on building a cone because a cone was for me kind of difficult at first to try and figure out not just really how to build the cone, but more how to texture the cone because I wanted the cone to be textured in such a way that the texture that's on it is wrapped around it and wrapped on it, as opposed to just, you know, the same slice over and over repeated, as can be sometimes done if you're not really sure what to do to start off. At least that's what happened with me. I couldn't get a cone to wrap properly with the correct texture. So let's take a look at the texture I want to put on here. So you'll see here I've got this smiley face. And now the thing to remember is that a cone has two main parts that we're going to be drawing. Right? Even though we draw it as like this, that's a good cone by the way, the bottom portion is separate from the top portion. So essentially I have a bottom portion which is a circle or a triangle fan. So it looks like a pizza pie with a bunch of slices, but then it has a top portion that is also made of a bunch of triangles that are stacked next to one another like this all the way around. Okay. And so each one of these is treated kind of separately. So in the algorithm, I draw them each separately. I start off by drawing the triangle fan at the bottom, right? And its origin is 0.5, 0.5, and that just makes it easier for textures when I'm wrapping them. And then of course 0.0 for the Z coordinate so that it's right there at the origin. And then I use a little bit of math. So if you remember your trigonometry, you're going to be using cosine and sine to find the different points. And essentially what this does is it draws 1, 2, 3 vertexes for the triangle, and it uses these same coordinates on the texture as well. And so this is what it kind of looks like. So my center coordinate is going to be right here, and this is going to be the bottom of the triangle fan. So this is going to be the triangle fan right here. The central coordinate is right here at the bottom. But then what I'm going to do is I'm going to come up and I'm going to draw coordinate number 2 up here, and we draw coordinate number 3 here, and then they get connected together. And then for the remainder of the fan, it's going to be the same thing. Coordinate, or the origin, and then coordinate 2, coordinate 3, and connect those together. And then coordinate 1, 2, 3, and then those are connected together. And it's going to go all the way around like that until I've essentially drawn a triangle fan and use those same points as coordinates for where on the texture I want the slice of the picture to be taken from to draw on that particular triangle. So for this triangle, let's just say that the coordinates are 0. And these are just arbitrary numbers, by the way, so don't take them for what they are. So this is 0, this is coordinate 1, and this is coordinate 2. This is what it's drawn in space, and then on the texture, these same coordinates will correspond with those coordinates in space. Likewise for the next triangle and the next one and the next one all the way around. Well, for this one, let's say this is coordinate 2, there's coordinate 3, and here's coordinate 0. These same coordinates will also be used for this texture as well. So it's going to take this slice of the texture and draw it onto this triangle in space so that my texture comes out looking like this smiley face. Now, the other part of this algorithm is the next portion, and this is all done in one for loop just to make things easier. But in the next portion, here's my side triangles. Now my side triangles use the same origin, 0.5, 0.5, except for I added in here a length variable for z. And this is going to tell me how long the cone needs to be. And the reason I use length is because the cone is drawn sideways, and that's it. So instead of drawing it at 0, 5, 0, 5, and then 0, 0 again, which would be at the same point as, or the same point as the triangle fan above, instead it's going to extend that z value out so that the triangles are instead not drawn flat, but drawn longwise. So instead of being drawn, here's my triangle fan kind of from the side, if you will, like a 3D view. Instead of being drawn like that, it's still drawn in a circle the outer points, but my central point is drawn up here. And so my triangles end up being stretched out like a circus tent or a teepee, something like that. Okay, so this fan combined with these triangles here end up making the full-size cone. So going back to this, again, I'm going to be using the same math as before in my trigonometry, cosine and sine for my side values, 0, 0 for my z value here, because again, this is going to be down at the bottom along with the triangle fan. My texture locations are going to be the exact same thing as before as well. I'm going to be using essentially the same locations as what I did up here with the same, with the cosines. But here's the deal. With this one, I'm not drawing them in a circle anymore. So here, I needed to use those same coordinates for the points in space for my points on the texture. But this time around, because my triangle fan or my triangle cone is being drawn up and down, I wanted the texture to still be able to wrap around it appropriately. So this time around, the textures are using these points. They're drawing down here, and then a top, and then a bottom. And this is going to make one triangle, the first triangle in the series. There we go, just like that. Then for the next triangle in the series, the next one over, even though the points in space are going to be drawing using trigonometry, and here, all I'm going to be doing is like stepping to the next triangle in the series. And so what this is going to do is going to slice my texture into triangles. And these are great looking triangles, by the way. I hope you really drawn this smooth draw for some reason. But anyways, so my texture is going to be sliced like this instead. And what that's going to do is allow me to wrap the texture around the cone like this in that direction, as opposed to making a circle along the bottom. And I'll show you what that looks like when I run the program. So that's what this texture or texture X location is. Texture X location starts off as 0. And then what I do is I increment it up every time I go through this loop with this texture step variable. And that texture step variable is based off of how many sides there's going to be. So if I'm going to make in this, like for instance here, if I'm going to make 4 sides, then my texture step is going to be 4. And it's going to start off here at 0.0 for my X location. And then it's going to continue on to 0.25, then 0.5, 0.75, and then ultimately pretend that this is over here is going to be 1.0. And up here, it's essentially going to take this value and divide it by 2. So this would be 0.25 divided by 2 right there. Okay, and my y values are simply going to be 0.0 and 1.0. Okay, those are my y values here, and those don't change. So it'll be 0 at the bottom, 1 at the top, 0 at the bottom, 1 at the top, all the way across. My x values are the only ones that I really have to keep track of because they're going step by step like this from left to right. So what this is going to do is it's going to make kind of a distorted version of the picture, but it'll still be wrapped around. Now you can obviously modify this algorithm at the top if you want to. Like one original version that I had the center point always as the x value for this top portion of the triangle. So what that did was it actually made the triangle slices like this. And again, that caused some distortion in the picture too, but maybe it's distortion that you're okay with. It really just depends on what you want. But I found that that kind of stretched out the texture in a weird way. So I kept it in this configuration instead. And there's a variety of different ways to approach it, but this was the one that I found was the best. Honestly, if you really wanted your picture to wrap around the cone perfectly, then you would need to Photoshop that texture to match these triangle slices a little bit better. But that's a little bit extra work that you maybe don't want to do. So anyway, so let's take a look at what this essentially does. So let's go back to the Scene Builder portion of the app, and we're going to build a cone together from scratch. All right, so I've included in here this commented section showing you how to essentially build a shape, but we're going to build one together real quick, and I'm going to comment this portion out so we don't have to worry about it later on. We're just going to build this from scratch together so you can see how it's done. So I'm going to start by making a GL mesh object, and I'm going to call this one gmesh. Actually, I'm going to name it cone, C-O-N, and then we'll call it gmesh01, just in case I have more cones later on. All right, and then from there, what I want to do is I want to give it some parameters here, so some properties. So I'll start with the gmesh, cone gmesh01 p. These are the properties here, and these properties are all going to be for the different aspects of the cone. So we'll start with the colors. So the colors are going to be, in this case, 0.0f, because I want my x value, or sorry, my r value to be 0. I want my green value to be 0, and I want my blue value to be 0, but I want the alpha to show through. So that's going to be RGBF. Then my next one is going to be scales. And so I want to scale this up by 2. So it's going to be 2.0f for x, a 2.0f for y, and a 2.0f for z. And there's my scale. Now these next three properties are for rotation. And the first one is going to be for degrees. So in this case, I want to rotate my cone 90 degrees in the x-axis. So it's going to be 90.0f. And then because it's the x-axis, I'll put a 1.0f here, and then 0.0f for y, and 0.0f for z. For the next one, this is the y rotation, but I don't want to rotate it all in the y-axis. So it's going to be a 0.0f for the rotation, 0 for x, 1.0f for y, and 0.0f for z. And then the next one is the z rotation, and again, I don't want to rotate it, so 0 degrees, and that's 0 for f because it's not the x-axis, 0 for y because it's not the y-axis, and 1 for z because it is the z-axis. So you'll notice here, what I've got is 1, 1, 1 in a diagonal. This is letting the properties know that this rotation is for x-axis. That's why it's a 1 here and 0 for the others. This rotation is for the y-axis. That's why it's a 1 for y. And this rotation is for the z, which is why it's a 1 for z. And that's it. And I did that on purpose so that it could separate out the rotations. And you can rotate each one independently as necessary. All right, so the translation for the x-axis, I'm not going to translate it anywhere. I'm cool with where it's at. So for x-axis, it's going to be 0 translation. For y, it'll be 0 translation. And for z, it will be 0 translation. And then finally, for the last one, these are texture scales. And I don't really use these too much. They don't really do anything. So I just leave them at 1. And you can leave them at 1 as well. And then there we go. There's my properties. And those properties will get passed along with the gmesh struct that I created. All right, so the next thing that I want to do is I want to define the texture that I want to use. So in this case, I'm going to say define, and I'm going to call it texture. And then I'm going to say in quotes, this is going to be smiley.bmp file. And we'll find out in just a second. After that, I'm going to say the cone.text file name is going to be equal to, and I wrote a macro for this. This is going to be concat, and we're going to say the texture folder location, comma, and the texture. So it's essentially going to concatenate those two things together. Oops, texture, there we go. And that's it. So it's going to concatenate the texture folder location, which I mentioned before is this right here, and the texture file name, which is this right here. So it's going to put those two things together, and that's going to be where my texture can be found. And the reason I did it like that is so that when you take the .exe file off of your computer and pass it to some other computer, after the build, that texture gets put into the exe. So you don't need to pass along the folder of textures along with the exe. You can run the exe independent of any other things that you might normally need otherwise on a computer or on a different type of program. So in this case, I made it so that like if you built this program and you wanted to show your friends, you can just give them this exe file along with the the glue file to go along with it. So anyways, back to this. I'm going to say that the we'll say the length, or in this case, how tall it's going to be. We're going to say it's going to be 2.0 f. That should be good. And so it'll be kind of a tall cone with the scaling that we have in place. We don't need a height, but we're going to say the radius, excuse me, the radius, we're going to make that a 1.0 f. Oops, 1.0. For the number of sides, I think I'm going to go with 12. 12 is a good number to kind of illustrate what I've got going on here. And then finally, we're going to call our shape builder class, and we're going to say we want to build a cone. It's in the cone mesh to it. So it's going to build it. And then the last thing we're going to do is we're going to take our scene vector and we're going to push back the, not that, we're going to put the cone mesh that we just built. And there we go. That should be it. So what I've got here is I've made a cone mesh struct object. I've input all the properties, color, scale, all the rotations, and where I want to translate it to. I've told it I want to use the texture of smiley.bmp. I've concatenated the texture and the texture folder location together into one texture file name so that it can find it later on. The length is going to be 2, the radius is going to be 1, number of sides is going to be 12, and then I'm just going to build it using my shape builder static class. And so with that, we should be able to build this and see what it comes out to, and be really disappointed if it doesn't. But yep, see, it failed to load the texture. So this is probably a PNG, and that was my bad. And that should fix that. Oh, awesome. That is exactly what I didn't want it to do. So that's great. And so as you can see, I've got some sort of issue here where the cone is not drawing properly. That's why. So let's do some real quick troubleshooting here. Let's see, I've got, oh, maybe that's it. Because I put zeros for all the colors. Let's go ahead and change that. And then we should be able to see the texture. There we go. Perfect. All right. And there we go. So now what I've got going on here is, of course, the fact that the texture has been scaled to a weird thing. But as you can see, I've got the smiley face going on here. And if I switch this out, you can see my triangle fan there at the bottom. There it is. And what it's essentially done is it's split my smiley face into a bunch of different pies. And so the smiley shows up appropriately on the bottom. And if I go down here to the actual cone portion, you can see, even though it's upside down, unfortunately, you can see that the smiley has kind of been distorted by the fact that the triangles are all slices of that smiley, but in different positions and with a different top of the cone, essentially, a different top vertex. And that can probably be fixed with a different type of algorithm. I just didn't feel like it because I figured it would be easier to kind of Photoshop how I want the texture to appear instead of having to come up with an algorithm that fits for every single texture. But maybe that'll be something I do in the future. So coming out of this, one thing that I do want to actually try here is if I change these scalings, I want to see if that actually will work and give us a different output. And it won't, so I'm not too worried about that. But what I can do is I can change the scale of these down. Be able to see, and actually I'm going to change this also to a -90 so that it rotates it in the correct orientation around the x-axis. So it's up and down. There we go. That's what I was looking for. All right, so there is my smiley again. Once again, kind of distorted. And then at the bottom here, oh, that is exactly not what I really wanted it to do. So that's kind of cool. But then there you go. So you can play around with actually a lot of those properties. You can see the best way to get your texture to show up correctly. But I thought this was kind of a cool algorithm that I wrote in order to get the textures to appear, for the most part, appropriately around the outside edges of the cone. And what I mean is, like, if I change this to say something like, I was using this one earlier, a pyramid looking thing, pyramid 0, 1, and is going to go ahead and make it look kind of like bricks. And I thought this was kind of neat because what it does is it doesn't repeat the texture over and over again, and it gives it still that kind of natural look, as you can see. And then at the bottom, what it's done is essentially just kind of like put the texture on there as one solid, one flat piece in normal view. Now, again, changing around the properties and stuff can definitely give it a different look. But for the most part, that's what you got going on there for that texture. So hopefully this was helpful in helping you understand how textures are laid on shapes. And if you want to, you can definitely use this algorithm in your own program if you want. I will post a link in the description. And again, thanks for sticking around and seeing what I've created. Oh, one last thing I almost forgot. I just remembered it right now as I was about to leave. Um, about the texture scaling and making sure that the texture shows up appropriately. So I want to show you something real quick here. So if I change the radius on, let me just get rid of one of these here real quick. If I change the radius on the bottom of the cone, that's going to change how the texture shows up. So let me show you what I mean real quick. I'm going to put this radius at 1. I'm going to change the scale back to 2 here. All right, I'm going to redraw my cone, and you should be able to see that, there we go, at the bottom of my cone, I've got my smiley faces all kind of like mirrored around, or not mirrored around, they're tiled around the bottom, okay? And so that's kind of weird. I didn't want it to be like that. I wanted it to be the full smiley along the bottom. But what I can do is get rid of that and come back to here. If I change my length back up to be normal, let me just double check, make sure that looks like a normal cone now instead of this weird flat thing. There we go. That's much better. Okay, so again, as you can see, my smileys are tiled along the bottom, which I'm not really a fan of. I don't want that right now in this particular case. You might, but if you don't, here's the real quick fix. Just change the radius. So in this case, I'm going to change the radius to 1/2. And since everything's based off of halves anyways, that makes this work out perfect. Now you may notice like, well, wait a second, now my cone is thinner along the bottom, which is kind of weird. So I'm actually going to come back here and I'm going to scale these back up. Since I went down by half, I'm going to double up basically the scale of the X and Y values. And so now that should be a normal size cone with a normal smiley along the bottom. And again, messing with those numbers can give you different size cones, obviously, and different size shapes. But keeping it at the 0.5 is going to keep that texture appropriate to where it's supposed to be. So I'm going to change this to 2 and that to 2. And I'm going to change that to 2 as well. So I've got a length of 1, I've got a radius of 0.5, and then everything is scaled up by 2. And so there is my cone, pretty normal looking. And if I look down at the bottom, there we go. My smiley face is exactly as it's supposed to be. There it is. And if you use the arrow keys left and right, you can see the triangle mesh and look at that in more detail. So there you go. So I just wanted to add that in there real quick. I just remembered it as I was signing off. So hopefully that helps as well. Change that radius. All right. Hope you enjoyed this, and I will see you in the next video. Thanks for watching.